system is a structural glaze system. So they start life as an empty frame. In this particular scenario, they're adding the glass to the frame, and then it gets delivered to site as a complete item. And there are benefits to that, and I'll explain why in just a moment. So they are all a panelized or a unitized system. And you can see here with these slides, generally you start at the bottom. In fact, you always start at the bottom, and then you continue to stack them up alongside each other and on top of each other through a series of male and female connections. Now, I've just put a little note at the bottom there that typically they're around 3.6 by 1500. These ones here are probably just slightly bigger, and they can vary in size depending on, of course, the wind loading. But, you know, it's really just floor to floor, so whatever the design of the building is, and it can be 3.3 or up to perhaps even 4 meters in height.
Hey Philip, when we're thinking about a glazed facade, so are you just thinking about the panels, or is it actually the structure that holds them in place? Where does it sort of start and finish?
Yeah. Yep. So the structure, yes, does hold it in place, Matt, because they are effectively, you know, when we sort of talk about curtain walling, if you imagine the description of a curtain wall is exactly what it is, right? It's actually a window system hanging on the outside of the building, being hung off the building, okay? And I've actually got some details showing the bracketing and how that connects the window system to the structure, just a little bit further on in the presentation.
Great.
So it's a good visual sort of representation of how that actually works. So the two panelized systems that we have are generally, and this is really just describing their visual appearance. So we have a flush glaze and a structural glaze. The flush glaze system, really the major difference between the two systems is simply the way of retaining the glass. But they do offer a slightly different aesthetic look. So with a flush glaze system, this particular one is actually, it's a male-female connection, comes together, but it's a one-piece section. So it's actually the aluminium, which is retaining the glass into the frame itself. Whereas the structural glaze system is actually the glass just glued directly into the aluminium frame. Now, as I mentioned before, they generally go out as a complete unit. That's probably more in the case of a structurally glazed system, because the glass obviously then has to be glued into the frame before it leaves the factory. A flush glaze system can still be site glazed. So if access, for example, is difficult or it's tight, then sometimes it's beneficial for a flush glaze system to be used because they're effectively an empty aluminium frame, can be lifted into place quite easily, and then the glass is fitted at a later date. The structural glaze system, that will be fitted as a complete unit. Now, there are some benefits to using a structurally glazed system, and that is simply that when it's fitted into place on the side of the building, it makes the space in behind it directly available for other subtrades to use. So it actually has a positive net effect on the building project if you use a structurally glazed system. Comes a little bit more expensive, so it's a little bit of a premium to use that, but I think it's actually offset by the potential gains you may have in the lead times. So again, that's just a sill pro. Yes, Jeanette?
Can I just ask you to clarify that? You say structural glazing may have benefits in the project timing. Is that because the building's closed in? Is that
correct?
What you're making?
That's exactly
because
right.
The building's closed in when the panels arrive. Yep. Okay.
Yep.
Thank you.
Yeah, because I think, you know, typically when you use a flush glaze system, you may still then wait a week or maybe 2 weeks for the glass to go in. Of course, at that point there, the building is still open to the weather.
Yeah.
Hey, sorry. I feel a little dumb, but which side of this is the weathering side of each of these?
Okay, so we're viewing it from the outside.
Okay.
Yep, so the glass,
So the structural glaze one is actually kind of less flush, or is more flush than the flush glaze one?
Yeah, you're right, actually, it is.
Okay,
yeah.
Sorry.
No, that's good.
That's just what was confusing me.
Yeah, no problems at all. Good question. Yeah, so the glass is generally on these systems usually positioned towards the front of the section. So we're looking at it from the outside. And again, that's just a sill section with a sill tray showing the relative difference between the two systems. And obviously they do offer a different aesthetic. So, you know, the image at the top is a structurally glazed system. It's quite clean. You know, you just really see squares of glass with black lines in between them. Whereas, you know, the lower image, you can actually see those mullions and transoms expressed through the glazing. So that, you know, it depends on the aesthetic that you're looking for as well and what you're trying to achieve. So this is actually, I took these photos last week because I thought, well, how do I explain how they resist air and water infiltration? So hopefully, I'm not sure if you can see my, my mouse cursor. Can you guys see that? Yep, cool. So this is a split transom on a structurally glazed system here that we're looking at. This is actually, in here is a pressure equalized space. So the water, so in the background, you can see a vertical mullion section, and that obviously comes down, the vertical mullion runs down to the bottom of this section's here. So any water that gets in behind the glass at this point here enters a pressure equalized space here and then drains out through here, okay, for a split transom. Equally, in a vertical mullion situation, so we've actually got, what happens here, because it's a male-female connection, this is effectively one side of a panel, and this is the other side of a different panel, but they come together and meet in the middle here. So this is like it's a seismic joint, and this is also a pressure equalized space in here. So, you know, any water penetration in through this area here goes through and it drops down into this split transom, or in some cases a sill tray, okay? So that's how it deals with water penetration and air infiltration.
Philip,
Yeah.
can I just ask you to clarify inside and outside once again on those?
Absolutely, yep.
No,
That's totally fine.
Yeah.
So on the outside, this is the glass. So we're looking on the outside here. So this is actually a structurally glazed model that we're looking at here. So this is the inside, okay? So this area with the big box generally is always on the inside of the system. And so the glass is always on the front face here. It's not quite visible. It's probably so obvious in this particular image.
And we're looking at a brackets that support the mullions there, are we also?
Yeah, actually, no, good point, Jeanette. So just here on this top view looking down, you can see this is a lateral load bracket. So it's like a hook bracket hooking the system over structure, okay? I've actually got some images a little bit later on in this presentation, which probably demonstrates that a little bit more clearly, but well spotted, Jeanette. That's very good. Yeah, there's a couple of lateral load brackets there. So, hey, look, when you're designing a facade system, the considerations are movement. And we've broken that down into two sections. There's actually a third one, which I won't really talk about today, but it's actually thermal. But the other two, the major ones, are really seismic and wind load, because that's where you actually get most of the movement in a glazed facade. In the case of a seismic event, the ground moves first, and then the rest of the building is trying to catch up. So, of course, that's why the system is built around a series of male-female connections. So not just vertically with the vertical mullions, but also horizontally as well, because earthquakes don't just move like this, they actually move up and down as well. So this building here is actually the Christchurch City Council building. And this is a double skin facade actually. So it's actually got a single glazed, structural glazed system on the outside and a double glazed, flush glazed system on the inside. But we took some images of the structural glazed system on the outside after a seismic event. And you can see on this lower right image where the vertical mullion sections used to line up, the glass and the glazing lines, they used to line up, but they no longer do, because obviously it's had a seismic event like this, and those vertical mullions have actually now moved, and they're now off center, if you like. So there's no way of actually fixing that facade. I mean, it did its job and it's kept its, the occupants safe. So one of the other things about a facade system, as well as having to move seismically and protect the occupants against, you know, the weather and the outdoor environment, it also then has to keep on protecting them. So in this particular case, whilst we've seen movement in the facade, I can tell you that that was about 8 years ago and that building is still being used today. So the only way of actually fixing that facade system, if you wanted to kind of bring those vertical mullions back into line, is you'd actually have to pull the whole thing off and then put it back up again. But of course, no one's doing that, and certainly not in Christchurch when you have, you know, all the aftershocks that they have. So that's actually a really good example of a facade system working in a seismic environment. This is it's a bit of a hero shot actually for a recently completed project in the Waikato. So Porter Group, who have all that lovely heavy equipment that they hire around the place. And this was really just to demonstrate that bracket connection back to the structure. So the image itself, firstly, I apologize because the detail I've got showing is obviously not relative to the image that we have on the slide, because the image has the structure going horizontally with a vertical mullion and the bracket connected to it. This DWG snip that I took obviously shows a vertical structure, but it's really just demonstrating the relationship between the vertical mullion sections on a glazed facade system, the bracket itself, and then the connection onto the structure. Is that quite clear to everyone? Yeah. Cool. And in this particular case, we're obviously looking at it from the inside as opposed to the outside, just for clarity. So the other consideration when we talk about movement is wind load. And New Zealand is a very wet and windy country. Glazed facade systems typically, you know, the wind pressures are expressed as a ULS and SLS. So if you don't know what they are, a ULS is an ultimate limit state and an SLS is a serviceability limit state. To give you an example, in 3604, of course, they're broken into wind zones. So a wind zone, say very high, for example, expressed in a ULS and SLS are those numbers below. They're pretty modest for a glazed facade, to be honest. Usually they're specifically designed, and they always are, because simply as you go up on a building, so does the wind load increase. Working on a project in Wellington, I have been over the last 18 months, as a 10-storey apartment building, and they have a negative ULS figure of 4.9, which is about the highest you'll have in New Zealand. So to give you an example of wind load, that would probably cover a building up to 6 stories high with those ULS and SLS figures. This actually is a 6-storey building, which is in Wellington. This is the Clyde Quay Wharf, and what we would typically see on a facade system or a building of this scale with this sort of scope is you get a wind map like this, which is clearly actually demonstrating where those wind loads are and how it's affecting the building. And again, they're actually expressed, in this particular case, these ones are expressed as positive pressures, but we actually do get positive and negative pressures when we're designing facade systems. By contrast, if you're going up, and just to sort of give you an idea of the sort of wind pressure you'd expect if you're building a 20-storey project, you could get wind pressures up to 3.4 kPa ULS. As I say, you know, in New Zealand, you probably wouldn't get much over 4.5 or possibly 5. Now, these are the 3 criteria that we use when we assess our window systems. Obviously, wind load is pretty obvious. That has a fairly profound effect. The span is generally the height of the system, and the spacing is the centers between the mullions or the glass panels, if you like. And if you change any one of those 3, it will affect the other 2. So just look at that in isolation. So a typical facade system, so as I mentioned before, about 3.6 high by 1500 wide. Now, the graphic here is showing the loaded area on the glass. So that's actually how the wind load actually hits the facade and is distributed out to the corners of the facade system from the center mullion. But that shaded area is what we call the loaded area. Now, on a 6-story building with that SLS, it's equivalent to about 740 kilos. And with a 20-story project with that SLS, it's equivalent to about 1,200 kilos. So, you know, substantial wind loading on some of these facade systems. And not only they're having to deal with the deflection from wind, obviously water penetration, they're also always having to move with the building both vertically and horizontally. So all of that is happening at the same time in some cases. I guess we move on to aesthetics, because some facades can actually look pretty cool nowadays, obviously with the progression of technology. We're seeing lots of mixed use of our product with different systems, including cladding systems. This image in the middle here with all the irregular shapes is actually a structurally glazed system. You can't achieve that using a flush glaze system, just simply because it's all about the water management and getting the water out of the system. And a structurally glazed system tends to resist water penetration better than a flush glaze system when you're designing irregular shapes like that. It's actually a car park building, so even car park buildings can look good. So yeah, just a few shots of some buildings that have interesting facade systems. We see extensive use of box fins. This is just a snip of some details that I have, which I'm happy to share with anyone who may want them for their project. This is basically how our aluminium fin systems integrate with our facade system. This is actually demonstrating like an eyebrow detail, but of course you can just have the vertical fins, or you could just have horizontal fins if you wish. And that sort of really moves us on to shading, and I think that's where you start to see the use of these vertical and horizontal fins using a myriad of different systems. So I think on the left we've got timber box fins. The top and the middle are actually concrete fins. On the right-hand side are aluminium hollow box fins. And the one in the center is actually a stainless steel rain screen. So again, we're seeing a lot more integration with other products with our facade systems. And the rain screen is primarily there to control solar heat gain. Again, another project where they've used not just vertical box fins, but they've also used an ACM panel, so a composite panel, and they've actually replaced the glass and they've put the ACM panel into the facade system. And again, that's to create shading to prevent overheating in the building. And then, you know, mechanical engineer will look at a facade like that and then work out a percentile of how much of that facade should be either you want to frit it, which is like a shading system on the glass, or how you actually integrate a cladding system or a rain screen system to try and prevent overheating within the building itself. So it's not just the architect drawing what they think looks good. There is a science behind it as well. You know, you're probably looking at a percentile of shading on the facade to achieve a certain shading coefficient, which and ultimately that reduces the load on the building management system. So another example of an integrated facade system, again, they've actually used a cladding system. So it's actually a fiber cement sheet. It's actually a double skin system. So, and the reason why they wanted to do that was they wanted to, if I just go back to the first image, what they've done here, they've actually used the glazed facade system to look after all of the weathering, the movement, wind load, water, everything. You'll actually, there's no structure penetrating that facade at all. So they've actually wrapped the building in a facade system. So you don't then have to deal with those very technical E2 details and trying to manage the water where you've got structure meeting a facade system. So that's another good reason why you would use a glazed facade, because it actually looks after all of those essential considerations without having to have the structure penetrating it. But in this case, again, more from shading than anything else, they wanted to integrate a cladding system, and on the inside, they actually wanted some usable spaces on the inside of the facade system. This is how they achieved that. So they actually used an insulating panel inside the facade system, and this was all built as a complete unit before it was delivered to site. So you can see the bottom is the outside and the top is the inside. So on the bottom, you can see that double skin scenario with the cladding, and one of them is just projected out onto a rain screen using a series of clips. And on the inside, they've got that insulating panel, and they've actually finished it off with a pin board on the inside so they can actually, you know, use it inside the classroom environment. And lastly, this is a double skin facade system. So actually this is, if you remember the Christchurch building, the City Council building, it's the same structure. So this is actually a shot of the double skin facade and the grate that separates the two systems. And in between those two systems, you have a building management system operating. And the reason for why you would actually design a building with a double skin facade is, again, it's all about making the building more thermally efficient. So it actually eases the loading on the building management system. And I'll show you this next image. This is actually out of the shop drawings. They've actually got some aluminium Venetian blinds between the two systems to help in the solar control. So there's various methods of achieving that. You can either use a blind system, which again was hooked up to the building management system itself, or you can achieve it by using high performance glazing. And that completes my presentation. Thank you very much.
Okay, thanks there, Philip. Perfect. I'll take control of things from here. Hey, now in terms of Philip's used a little bit of extra time there, so rather than asking questions now, we'll try and wrap up at the end. And this there's a message that's been recorded. It certainly is. If you want to contact Philip, here are his details. Here's a philip.nagus@apl&z.co.nz. And our next presentation is by Andrew French from Jacobsen Building Systems. Andrew's going to be talking about terracotta facades. So cover another substrate. Andrew, looking forward to your presentation. Andrew is an ex-builder and has helped Jacobsen bringing these new terracotta systems into New Zealand, and has been managing the development of buildings over the last 7 years using their particular systems. And Andrew, you're going to talk to us about some of the considerations around terracotta facades. Over to you.
Thank you, Matt, and hello, everybody. I'm assuming you guys can see me, because one thing we do have to do here is perhaps get a PowerPoint thing going to see it on the screen. But what I'm going to do is just have mock-ups here. Hopefully you can see it clear enough, and we can go through the various systems that are utilised around the world, actually, and not just here.
Hey Andrew, just for everyone, if you want to make sure that you've got your view on speaker view rather than gallery view, then that'll that's right, and you don't have to do anything. Just make sure that we can all get a big shot of you and your great system. So over to you.
All right, so you can, I don't know how to do that, to be honest. I'm a bit of a technophobe, so hopefully you can do that.
Already done.
Okay, brilliant. So what I've got here, I'll take you just through a few of the installation methods first, and then we can go through the features and the benefits of using a terracotta system. Okay, so what I've got here is what's typically used around the world. And if you're doing it in Shanghai, this is probably the sort of system you would utilize. This is your backing, this is your substructure. Now, I've used plywood just purely for the fact it's more stable for a mock-up. You wouldn't get away with using plywood these days. It would need to be a compressed sheet or something like this. And then there's a wrap that goes over the top of that. Now that is your weather-tight layer on the building. That's what will keep everything inside nice and dry. So all of your flashing systems, etc., are taken back to that layer, right? What we then take care of is everything from that layer out. Now for this particular method, there's a T profile that comes off the brackets that are back on there. And then, so that is fixed back using either what we call a floating bracket or a fixed bracket. And that is dependent on your seismic requirements, seismic loads, that sort of thing. This is all engineered and designed for a site-specific work, so that we can help you take care of that. And then the tile itself is fastened back to that profile just using a clip system. Now I should say they're more restrained as opposed to mechanically fastened, right? Just these small clips here, they just have little gaskets that compress as you fit the tile into the system. What that allows is the tile to move within the frame. It's not mechanically fastened to the frame. So any seismic movement, any wind load movement, that sort of thing, the tiles are free to move. Obviously I can't move it too much. It's got to take a heck of a lot more force than I can generate, but that's the reasoning behind that. Now why I say you'd probably use this more overseas is you've got this space in here you can utilize for, say, insulation. Okay, you can wrap the building. There are plenty of rain screen installation products out there, or use it for your services, cabling, plumbing. You know, your downpipes and everything can run in behind here. So if you don't want to see that aesthetically on the outside of the building, use this space. All right, we can do that. And then, so then we, as I said, wrap it up, gets it all tight. The method here is then you have these, every tile is a labyrinth system. So I know you can't see this too well. Happy to send you all the typical detailed drawings and everything later on. Just get in touch. We can do that in CAD and PDF, whatever you need. But you've got this open joint here. It is a labyrinth. It's like a shiplap, you know, kind of like your weatherboard type thing. But there is a gap that will allow air in through here. Right? So that's constantly ventilating the space in behind. Now you probably think, okay, well, water can get in there too. Yes, it can. But when you think either rain coming this way or even horizontally, it's got to work its way up and around this labyrinth. So when it gets in behind the tile here, it's under no pressure. So all it's going to do is either just drop straight down the back of the tile, or because there's constant airflow in this area here, ventilating it out, it's just going to evaporate out. Okay. So the idea is that no water is getting back to your weather-tight layer. It's protecting that layer. So it's obviously going to be far more watertight for a heck of a lot longer because the elements are being stopped at this point here. Right, nothing's getting past the terracotta. Well, sorry, a little bit is, but nowhere near as much as what you would all normally associate with it. What we typically do in New Zealand, though, is because we still utilise the space in either the timber framing or the steel stud framing, that's where all your insulation goes, your cabling and that sort of thing. So under the New Zealand Building Code, for it to be a rain screen, you only need a 20mm cavity. We typically work to a 40mm cavity, and it's just using a rail system, a rail at each vertical joint. And then there's a horizontal rail to fix back to. The span of that will be determined by your wind load and seismic requirements, okay, for the site. So we can work with you on that. And then the rest of it is exactly the same as what I just showed you. The open joint allowing airflow and everything through there. Okay, so that's the typical method for New Zealand. Obviously, the benefit is you don't have any as deeper returns with your box out windows and that sort of thing. Don't need to be as deep. Right? So, and also if you wanted to run the tiles vertically in a format instead of horizontally, it's basically just doing it that way. Okay, so you have your rail at every horizontal joint. The only difference is the clips then clip in, go from here into the cavity.
Sorry, can I ask a question?
Yeah, go for it.
Does that mean that this unit you're showing us repeats sort of every 40 milli? Like, do you need one vertical aluminium backer for every 2 tile? Like, you understand what I mean?
Yeah, so this vertical rail here is only on every vertical tile joint. So let's say the span of your tile is 1200, 1500, 1800, whatever. You'll have one of those at every joint.
But so the tiles will express themselves as a single 1200 long tile,
Yes.
or will they? Okay.
No, correct. Yeah. So, I mean, this is just like this to typically, so I can carry it around. You know.
Okay.
It's not too heavy. I mean, this here, this tile is probably quite typical of the size tiles we're dealing with. This is a 600 by 300. So you'd
I
have
get it now.
rail here, rail there.
Yeah,
And
sorry.
then clipped at either end. No, that's fair enough. Right, so I'll try not to hold this for too long because it's rather heavy. But this is, as I said, a typical tile that we use, 30 mils thick, right? Combed, honeycombed sort of interior to help with strength, right? So it's a double skin. But as I said, this particular thickness can go up to 1.8 meters by 500. That can be the size of your format. If you want to go bigger than that, we can go 3 meters by 800 is the maximum tile size we can do. But you then go to a 40 millimeter thick tile. Okay, so that does increase your weight, obviously, but it gives you a much larger format. Now, Matt, can you, bring up that slide, the slides that I sent you. I just want to go through the first from 2 to 5, I think it is.
Right. Yep.
So that's the first one. Right. So this is an installation in London where there's multiple sites. So I'll just the ones I've shown you obviously need scaffolding and that sort of thing to be able to put them up, which is getting harder and harder to do in New Zealand because the spaces are getting smaller and smaller. So other ways of installing is this project here in London was installed using a unitized system. So Matt, if you just jump to the next slide, you'll see there the panels are made up on site, it's clipped together off-site, and then craned into place and installed in a unitized method. So Matt, if the next slide, you could bring that up, please. This project is the big tower on Central Park in New York, big residential unit. So you'll see there how you've got the terracotta tiles running full height, but again, they're made in pods off-site and then just craned into place. So that's another couple of methods of how we can install the terracotta system without having to use the scaffolding and everything. It can be done off-site and then craned in. Makes it so much quicker. All right. So Matt, if you can just pop back to me, and then we can flick through those other ones a bit later if we've got time to see some pretty pictures. So coming down to the style and design that you can do, one of the beauties about terracotta is it's only limited by your imagination of the style and design of the tile, okay? This big one I showed you before, again, that's fairly typical. You know, there's quite a few people around that could do this sort of tile and shape. You really only break it up with color. So what we can do is make virtually any shape that you want. Now this tile here is off a project down in Christchurch, where there are 5 different profiles that were designed by the architect. They came up with these shapes. We sent his drawings off to the factory, and they just came back to us and said, hey, that dimension just in here is just a little bit small. Can we make that a bit bigger? so it'll handle the New Zealand wind loads that we have to deal with. Other than that, we're good to go. So we made 5 new dies, all slightly different. But what that did is, because it's installed in a vertical format like that, it became 10 different shapes, because all we're going to do is flip it over like that, and it's a different profile. Okay? So that's something unique for that building. But because we still own, NBK, but essentially own the rights, the dies and everything, it can be utilised by anybody. So what we do is, if you want to do something unique, you tell us what the shape you want it to be. We'll advise, yep, no problem, or hey, let's maybe tweak it a little bit, and you can create something unique for yourself. Okay. Or there are sort of standardised some profiles. You maybe see this as opposed, just having a ribbed surface on it. Again, that can run that way or that way, just whatever way you want to do it. And you can have multiple formats on the same elevation. So I don't think you have to stick to the one design, okay, on the building. You can change it up. All we have to do is come up with the subframe system is how we can fix that back to the building. All right, but that's our job. And then you can maybe see here lots of different weird and wonderful shapes on there. And then the colours. There's about 20 natural clay colours. I don't know if you guys can see these. And what I mean by natural clay is there are no colour additives. Okay, this is purely just depends on what mine it comes out of Europe, what clay mine, what part of Europe that clay mine is in. And then just the mixture that they do at the factory. It's good to know your projects in Shanghai, because that's where we get our stuff manufactured. So the lead time will be nice and easy. We're just up the road. Okay, so no problems there. But all the clays and everything come out of Europe. So Shanghai is just a manufacturing site for them. There's other factories in Germany and Portugal. Okay, so, and you may be able to see, you probably can't, there's a colour difference between the core of the tile and the outside of it. That's just purely, the temperature it's fired at. It's going through a kiln at over 1,000 degrees, right? So any impurity in the clay has already been burnt out. There's no risk of fading. The colour fastness of terracotta is phenomenal. It really is. So it'll last forever. The beauty about it is once it's on the building, from a maintenance point of view, you never ever have to touch it again. Okay, there's no coatings on it, there's no painting, no sealing. Okay, it's all just natural material. Okay, so that's a huge benefit for your clients further down the road. And obviously, Phil, I need to buy you lunch because you didn't show any terracotta fins in your presentation. Okay, so we can do that as well.
Send me some pictures.
Yeah, some different pictures. So Matt, if we can just go back to that. I know we're conscious of time. We're running out. So Matt, if we can just go back to that slide. Now, just some variations of how it can be. That's a massive building in Russia somewhere. Just flick through them, Matt. We can talk. This one I just wanted to show you really to highlight the different shapes that you can do, right? It doesn't need to be a boring flat surface. You can really mix it up. Okay. Pop on to the next one. This is in Auckland. This is one of our larger installations that we did. I remember about 2010, 2011, the accommodation units there. All of those are just natural colours. This one's in Wellington. Probably a little bit more familiar if you've been in Wellington. This is a pretty exposed site, but we can, again, design the tile and design the system to suit the site-specific wind loads. There's really nothing that's too big. And this one just shows you, I'm just trying to highlight the size of the panel. Those are big 3-metre panels. They're not 800, but they're still pretty long span, and they are just fixed top and bottom. The building on the right there, the office block there, down at Christchurch, the panels across the top are actually 3 metres by 800, and then the rest of them are just various sizes to suit. Just fixed top and bottom. There's no mid-span fixing. Again, Phil, great. We can do some screens, some baguettes, they're called, over a glazing system. So you and I obviously need to sit down one day So that's, I'm not sure where that building is. It's not in New Zealand, but it's just to highlight something you can do for your sun shading, your solar shading. And we can also do those mechanically if you want to. So we can have a mechanical louver system that moves with the sun. And again, just different shapes of a screen. And did I have another one? Okay, yeah. So just to quickly summarize, there's no restriction on your building height. Go as high as you want to. Installation methods to suit the site requirements and your design. There's multiple colors. Multiple natural colors. What I didn't mention is you can have any RAL glazed or any color in a glazed finish. Okay. Limited by your imagination. Site-specific wind loads, etc., are all engineered, and it's virtually maintenance-free. Once it's on the building, don't touch it. You don't have to. Let Mother Nature do the maintenance for you. Okay. So, and like I said, if you want any typical details, typical design details, by all means, get in touch. I can send them back to you. And any questions that pop up, more than happy to help you out. It's not a complex system. Okay. I know Jeanette mentioned right at the start, you're looking at complex facade systems. The beauty about this is it's not complex at all. It just looks complex. It's really quite straightforward. Okay, thank you guys.
Right, thanks Andrew. I've just got your contact details up on the screen there. Now, Jeanette, I just sent you a note saying maybe if we could look at doing the EBOS intro at a later date. I wouldn't mind just seeing if we've got any questions or comments around the presentations today. So if you're okay with that,
I'm absolutely fine, Matt. They were really great presentations. Thank you, Andrew and Philip. Philip's comments were really helpful to clarify a number of the things we've been talking about during the course, and Andrew, you introduced me to some exciting new possibilities there. It was very helpful. Thank you.
All right, so these are two very low maintenance, high performance cladding systems, which actually, you know, the great thing here is you don't have to use one or the other. You know, often there's a combination to create the effect performance you're looking for. So anyone got any comments around or questions around the information today? Okay.
I've got a question.
Thanks, Jeanette.
Andrew, I'd like to know a bit more about the production process of the tiles. It's molded terracotta. You use earth or material from all around the world, I think you said, and a lot of it's made in Shanghai. Can you just give us a little bit more of a, you know, I mean, Louis Sullivan famously used terracotta tiles on buildings in the late 1800s and early 1900s, and they are highly ornate and they're extraordinary buildings. And so I'm excited to see terracotta kind of come back into the market, but I'd quite like to know a bit more about how, you know, the material and how it's made.
Sure. Well, the clays in Europe are the better clays, the best clays. So there's various sites, mainly around Europe, where it's extracted from. Then we'll go to whichever factory requires that colour or order. As I said, we use the Shanghai plant purely for lead time purposes. You know, it's only a 3-week shipping, so it's much quicker. But it goes to the plant, it gets washed, gets cleaned out. It will then go, basically, depending on the colour of the order, it just goes into a huge big mixing vat, where it's again, there's a lot of recycled content in the terracotta too. So every production, they produce more than they actually need. So if those tiles aren't utilised, they just get crushed and put back into the production system. A die is made, and what I mean by a die is it creates the shape that you want it to come out to. The size of that die depends again on the colour, because clays shrink at different rates. So you may need different dies to create exactly the same size tile in different colours. But again, we can take care of all of that for you. It just gets extruded out. It's just pushed out through the die. Obviously comes out wet. So it dries off for a period and then goes through a kiln. And it's a pretty massive big kiln. It's about 200 metres long. Goes through there at various temperatures. The higher in the middle, obviously, over 1,000 degrees. Comes out the other end, it's stable. It's not going to move from there. And then it's cut to the lengths that you need and supplied. So we can either do factory cuts to the dimensions. What we will do though is we will order tiles that are slightly oversized, particularly for your corners and perhaps going into windows that can be cut on site, because we all know builders don't build things quite to the exact measurement. So we do have to allow for that. So that's basically the process. It hasn't changed for, as Jeanette said, for hundreds of years, really. It's pretty much the same process as they used back in the 1800s. It wasn't until the 1990s, an architect called Renzo Piano was commissioned a site in Berlin that was used to be part of the wall. And he came up with the idea of hanging the terracotta off the side of the building, as opposed to bonding it to the building, like you would, say, tiles in a bathroom or something like that. We just got asked the other day, actually, about looking at a site in Auckland and Wellington that was built in 1930 something, where they've got bonded terracotta tiles and they're just replacing a few of them. So we're working out how we're going to do that, because it's a kind of a forgotten skill, if you like.
Hey, thanks, Andrew. Hey, that's 12 o'clock. Now I'm going to go back from gallery view just to speaker view, and we're just going to put a poll up now, because I'm interested to get your feedback to make sure that you. I just want to get your feedback on the content. On there, it's talks about the our EBOS presentation, which I haven't done today because I figured Andrew and Philip had us in the palm of their hands with these great introductions to 2 facade systems. So, Jeanette, if we can do that another time, that would be great.
Sure.
Can you give us some feedback? And Jeanette, if anything sort of has stemmed out of this or any other questions, we can cover that off in a later session. Just let you know when you'd like me back.
Thank you, Matt, very much. I thought that was very successful. An hour goes by pretty quickly, and there was a lot of stuff to cover there, and I thought particularly useful and helpful. So I'd like to thank the presenters very much. And I'd like the students to fill out that poll for Matt, and thank both the presenters and EBOS for a really helpful presentation today.
Cool. Hey, thanks, Jeanette. Pleasure as always. Oh, thank you, team. I didn't see much yawning going on there, so I think that's a big thumbs up to Phil and Andrew. Thanks, thanks, guys.
Yeah.
Hey, I wish you well in your assignments and studies, and look forward to catching up in the next few weeks. Jeanette, just keep in touch. And we've recorded this, so I'll send through a link. You've got Andrew and Philip's contact details if you need anything else. Other than that, have a fantastic day, and all the best for the rest of your studies.
Thanks so much, Matt.
Thanks, team.
Philip and Andrew. Cheers.
Thanks everyone.
Brilliant. Really, really useful.